Hi everyone, I am Napur. Today we are solving LeetCode problem 190 reverse bit. In this problem, we need to reverse the bit of given 32 bits signed integer. Means if we have a number n, we need to reverse its binary number. This number's binary digit of 32 bits. We need to reverse those 32 bits. Then we need to give the output of these reverse integers, these reverse bit. We need to give the output as in decimal. So yeah, so firstly we are just reversing the bit of converting this numbers into binary. Then this is the binary form, and then reversing these 32 bits, and then after converting these 32 bits we will return the decimal of this number. Approach of this question for solving this problem, we will use the similar approach as reverse integer. So in reverse integer, what we were doing is taking any variable, let's say answer, and multiplying it with 10. So our last digit of answer will be 0, and after that adding in the reverse format, getting the last digit of the number by modulating, and then adding that last digit to the answer variable, and one by one we will adding those digits, and then we will get the reverse digit, but reverse number. But in here we have to deal with binary digits. So in place of using 10, we will be using 2. So I will code now to explain. Firstly, we will be taking an variable, let's say here answer, and taking it as 0. Then using a for loop for underscore in range of 32 times. So this loop will go on for 32 times, reversing all in bits one by one. Now we will firstly multiply it by 2. Why? To create the left shift. So left shift means creating a space for another digit in the right side. So we are multiplying the number by 2, so we are creating a left shift. It is like a left shift binary bitwise operator. Answer multiply equals to 2. Then we will add the number answer plus equals to, we will add n divided by 2. So this will give us, we will do the flow division. So this will give us we need to do here modulus. Okay, I'm forgetting. Yeah, sorry. So here we have used a modulus operator to get the last digit of that number. Means if this is the number, then its last binary digit will be modulus 2, and so we will add that modulus 2 to the answer in the left side, because we have created a left space here, and then we will just divide equals to 2, which will remove the last digit from the number, and then we will return simply return n, not an answer. So if I submit, okay, all test cases are passed, and if we run it, yeah, if we submit it, it is same as the in reverse integer bit, but because the reverse integer, it is similar to that, but that is for decimal numbers, and this is for binary numbers. We are using 2, multiplying 2, dividing by 2, and taking the modulus by 2 to get the last digit, and to do the left shift, and to remove the last digit. And this is the similar approach as reverse integer. And so yeah, thanks for watching.